Geometry opens your third eye. With every problem you solve, your mind becomes sharper and cleaner. We have a large semicircle with a smaller semicircle inside it. The smaller semicircle's diameter has both endpoints on the arc of the larger semicircle, and its arc is tangent to the larger diameter in this point. Before we begin, take a few seconds to think. Do you have an idea? Alright, let's solve it together. Welcome to Geomathic. The first thing that comes to mind is finding the radius of the larger semicircle. As you can see, the given lengths add up to the diameter. So dividing their sum by 2 gives us the radius of the larger semicircle. I write that 1 plus 2 equals the diameter. So 3 over 2 equals the radius of the larger semicircle. Let O be the center of the larger semicircle and M be the point where the smaller semicircle is tangent to the diameter of the larger semicircle. Now we can easily find the distance OM. We know this length is 2 and the radius of the larger semicircle equals 3 over 2. So OM equals 2 minus 3 over 2, which is equal to 1 over 2. So OM equals 1 over 2. Now let N be the center of the smaller semicircle and connect M to N, since NM is the radius of the smaller semicircle, and a radius is always perpendicular to the tangent line at the point of tangency, and M must be perpendicular to this line, which is the diameter of the larger semicircle. By connecting O to N, we create a right triangle ONM. The height is R, the base is 1/2, and the hypotenuse is ON. So we can use the Pythagorean theorem. ON squared equals 1/2 S squared plus the height R S squared. Now we have ON squared in terms of R. Let's keep this aside for now. If you look closely, another important key is hidden in this figure. The diameter of the smaller semicircle is actually a chord of the larger semicircle. And according to a circle theorem, if a radius passes through the midpoint of a chord, it must be perpendicular to that chord. We know N is the midpoint of this chord. Therefore, this angle should be a right angle. Now draw a straight line from O to this point and let's call it P. This gives us another right triangle, ONP. Its height is ON, its base is R, and the hypotenuse is ON, which is the radius of the larger semicircle, equals 3 over 2. Now we can apply the Pythagorean theorem once again. OP S squared equals R squared plus ON squared. As I said, OP is the radius of the larger semicircle, which is equal to 3 over 2. So 3 over 2 squared equals R squared plus ON squared. So ON S squared equals 9 over 4 minus R squared. Okay, now we have two equations for ON. Setting them equal allows us to find the radius of the smaller semicircle. So 1 over 4 plus r squared equals 9 over 4 minus r squared. Move these terms to the other side, then we have 2r squared equals 9 over 4 minus 1 over 4, which is equal to 8 over 4 or 2. So 2r squared equals 2, then r squared equals 1, which means r equals 1. So the area of this shaded region equals 1/2 times pi times 1 squared, which is equal to pi over 2. Let me know your solution in the comments and drop a like. Have a good time.